Hey y'all, welcome back. I know it has been a long time since we have been here, but you know how to do this. You know what we're doing. You got your packet right in front of you, just so that you know everywhere that you see a line, that's where we're going to kind of put something in. So when you're looking at this, let's first talk about today what we're doing. Understand the concept of slope. That's our new term, which is the change in y over the change in x. All right? And then we're going to graph. Probably won't get to graphing today. Let's start with the basics. So slope is the tilt or inclination of a line. If you need to pause and write that down, do so. Welcome back. It is also the ratio of vertical change, that's our change in y, to our horizontal change, that is our change in x. Again, if you need to pause that, do so and write it down. Welcome back. You also have this math tip over here. All right, so we are on page 1 of our packet. Keeping on that, if you look to determine slope, if it is positive or negative, you're looking like you're reading something. So going from left to right, do you see how that goes down? What do you think that would be, positive or negative? If you guess negative, you are correct. So going left to right, if it goes up, what do you think that's going to be? Positive. Nice. All right. Going on to page 3. As y'all know, I lived in North Carolina. I lived by the mountains. So when I'm driving through the mountains, I would see something like this. That actually means something. That has to do with slope. That's the awesome thing about this. It is so useful. So every time you go 100 feet, whether you're going up the mountain or down the mountain, every 100 feet you rise or fall 7. Isn't that cool? So I need you to pause and write that down. 7% is the slope of the road. It means that the road drops 7 feet vertically for every 100 feet horizontally. Also, slope is the steepness of a line. So you have a bunch to write down for this slide. Why don't you pause it, write it down, and then come back to me. Welcome back. All right. Still looking at that same page. Thinking of what we talked about from the first page. Reading left to right. This goes up. What kind of slope do you think that would be? Positive. Nice. Left to right, it goes down. What is that? Negative. All right. You're getting this. You're getting this. What about this? We haven't talked about this yet. What do you think that would be like? Not very much fun. 0 fun. So that's going to be our 0. And this right here, it's going to be a fun word. It is called undefined or no slope. Undefined or no slope. Again, take a second, pause this video, write that down. Welcome back. All right. Keep moving on to page 3. Talking about vertical lines. This line does not run, meaning run left to right. Think of how you run. You don't run 90 degrees up and down. You run left to right, okay? So it doesn't run, and all vertical lines have an undefined slope. The nice thing is, this is a vertical line. Vertical line, undefined. They kind of go hand in hand. So, what does an upside down and right side of V look like? So if you were to draw a V, and then where you were to draw one upside down, oh look, that kind of looks like an X, doesn't it? So a vertical line will always be X equals any number. And if this is a lot being thrown at you right now, don't worry about it. It is all good. We are going to continue working with this for a little bit, all right? So, going on to the next page. Horizontal lines. A horizontal line. It doesn't rise. It is 0 fun, all right? So, all horizontal lines have a slope of 0. This one's a little bit harder to see, but if you take an H and you turn it upside down, right? Go like this and go like this. That's an H, right? Hey, that kind of looks like a Y. I see what they did there. So that is a horizontal line. We'll always start with Y equals. And we will continue to talk about these equations as we go through this topic and through this part of this unit. All right, now the fun part. We are going to find the slope of a line. All right, we are going to basically start with our leftmost point. And in this case, I'm going to draw a line up, and then I'm going to draw a line to the left. Do you see how I did that? I started here and I went up on the graph, and I started here and I went left on the graph. I stayed on the points, on the line with the points, all right? Now, every time you see a box, you're going to count. So this is 1 box, 2 box, 3 box. Does that make sense? Okay. I stop once I get to where the two intersect, where the two lines intersect. So my rise, I will put 3, and now I'm going to do my run. So to get from here to here or here to here, doesn't really matter which way you go. 1, 2, 3, 4, 5, 6. So my run is 6. What does this fraction reduce to? What can go into both 3 and 6? 3, nice. So I'm going to divide by 3 on top and divide by 3 on bottom. That gives me 1 on top and 2 on bottom. So 1/2 is going to be my slope. 1/2 is going to be my slope. Again, that doesn't make sense? Give yourself some time. All right? So start here. We are going to, I'm going to do this a different color just to make it easier for y'all to see. I'm going to start at my point and go up. I'm going to start at this point and go left. All right? Now, from here to here, how many boxes is that? 1, 2, 3. So the rise is the vertical, the up and down. So it's going to be 3 over from here to here. Remember, we're counting the boxes. So 3 over 4. Can I reduce that fraction? Nope. So that is my slope. All right. Now, looking at page 6 of your packet, we are almost there, y'all. 2.5 more pages. Missy Flip worked odd jobs all summer long and saved her money to buy passes to the ski lift at High Ratio Mountain Ski Resort. In August, Misty researched the price tickets and found several options. Since she worked so hard to earn this money, she wants to see what's the best deal. All right? So if we do daily lift tickets, if she doesn't go at all, how much money is she going to pay? Well, 0. Duh. What about one day? 30. Right? A daily pass, that means one day, is $30. So if we go 2 days, how do I go from here to here? Add 30. Nice. So that's 60. What about here? 90. Nice. 120. Are you beating me? I hope you're beating me. 150. Last one. 180. Awesome job. All right. According to the table, what is the relationship between the cost of the lift tickets and the number of days? What happens every time we add a number of day? What happens every time we add a number of day? We add how much money? So add, this is going to be kind of quick and dirty, but add 1 day, add $30. Does that make sense? Every time we go another day, or Missy goes another day, she adds another $30. All right? So if we are going to write this as an equation, right, we don't want to every single time have to say add 30, add 30, add 30, add 30, add 30. Let D represent the number of days, and C represents the cost. So my cost is obviously going to be my final. How much is it per day? 30. Awesome. And how many days? Well, that's what we don't know. All right? Now, what I want you to do is I want you to take a second And I want you to use your table. It should be just on this previous page, okay? So we're on page 7, and I want you to look back at page 5, and I want you to put this table into this chart, okay? That table into this chart. So 0, 0. At 1 day, she's at 30. At 2 days, 60. I know it's really hard to do this since the numbers are awkward. Just do the best that you can with what you're given. 5 is 150. 6 is 180. 7 is 210. All right. So we're going to label. We got our points. Then it says label the leftmost point A. And label the next 6 B, C, D, E, F, G. All right. Moving right along. All right. So once again, I used my graph, and if yours is not perfect, that is A-okay. Mine isn't perfect either. Just do the best that you can to get around the number that it should be. All right. So using this graph, it says from A to B, what's the vertical change? Okay? So where is A at? What is A's? A is this point right here. Okay? B is this point right here. So to go from here to here, what happens? How much does it go up or down? 30. Nice. All right? And how much does it go left to right? 1. What about from B to C? So from here to here, what happens? Another 30 again. Good. And here, 1. One more. From here to here. From 60 to 90, what is happening? Adding 30. Nice. And this is going to be 1. Do you see a pattern that is emerging for every single one of these? Oopsies, that's supposed to be 1. 1, 1. All right? It can be written in ratios. So vertical change is 30, horizontal change 1. Vertical change 30, horizontal change 1. Vertical change 30, horizontal range 1. Vertical range 30, horizontal range 1. You see what we're doing here? All right? Does that make sense? So, it's hard to see with this graph. It was a lot easier when you were looking at these. So we'll try and make sure that we have easy things to look at. Otherwise, again, you're looking at the change in Y, which is 0 to 30, 30 to 60, 60 to 90. Every time we're adding 30, so that's our change in Y. That's why it's the top number, over the change in X, which is from 0 to 1, 1 to 2, 2 to 3, 3 to 4. Do you see? This is how we got this whole entire thing. All right? And look at that. Done with this part. Make sure that you watch that slope do video because it's probably one of Miss Davies' favorite videos.